Hello everyone. Today I am starting chapter Ionic Equilibria, and in this video I'll be talking about ionic equilibrium, types of electrolytes, acids and bases. Ionic equilibria. The equilibrium between ions and unionized molecules in a solution is called ionic equilibria or ionic equilibrium. And some principles regarding ionic equilibrium we have learnt in chapter chemical equilibrium, and in this chapter we are going to study some principles to determine the equilibrium constant, concentration of ions and unionized species. And the first topic of the chapter is electrolytes and its types. Electrolyte: the substance which give rise to ion when dissolved in water are electrolytes, and the substance which do not ionize or remain in a molecular form in aqueous solution are called non-electrolyte. The electrolytes are classified into two categories, that is strong electrolyte and weak electrolyte. Strong electrolytes are the one which used to ionize completely when when aqueous solution is made out of that. Examples are strong acids, strong base and salts also. Weak electrolytes are those they used to dissociate in very small extent in aqueous solution. Weak acids and weak bases are belonging to this class. Weak electrolytes ionize partially in dilute aqueous solution or dilute solution, and when they ionized very partially, you would say, so what happened in solution, we will be having some ions and undissociated molecules also, or non-ionized molecules also. The ionization reaction therein represented by a double-headed arrow between the ions and non-ionized molecule. Now another topic, degree of dissociation. Degree of dissociation of any electrolyte is defined as a fraction of total number of moles of electrolyte that dissociates into its ions when equilibrium is attained. It is denoted by symbol alpha, and it is given by number of moles dissociated upon total number of moles. If we need to calculate percentage dissociation, we used to take simply value of alpha and multiply by 100. If C is the molar concentration of electrolyte, the equilibrium concentration of cation or anion is alpha multiplied by C mole per dm cube. Now, acids and bases. Acids and bases are the terms which you are very much familiar, but for describing these terms, three theories has been given. Number one, Arrhenius theory of acids and bases. Second is Bronsted-Lowry theory. Third is Lewis theory. Let's learn one by one. Number one is Arrhenius theory. According to this theory, acid are those substances which contains hydrogen ions in aqueous solution, or you can say that acids are those which contain hydrogen and give rise to hydrogen ions in aqueous solution. For example, if you have hydrochloric acid on dissolution in water, you will get hydrogen ion and chloride ion. If you have acetic acid, which is a weak acid, on diluting weak acid, you will get acetate ion and hydrogen ion. Arrhenius described hydrogen ion in water as bare ions, and they hydrate in aqueous solution and turn up into hydronium ion, which is represented as H3O positive one charge. We used to use hydrogen ion for our convenience only, but actually it is hydronium which is present in the aqueous solution of acid solutions. Arrhenius theory of bases base is the substance that contains hydroxyl group and produce hydroxyl ions in aqueous solution. For example, if NaOH is dissolved in water, it will produce sodium ion and hydroxyl ion. Ammonium hydroxide is dissolving into water, it will give you ammonium ion and hydroxyl ion. So, Arrhenius theory accounts for the properties of different acids and bases, and it is applicable only in the aqueous solution. And it does not explain the basicity of compound like ammonia or sodium carbonate. These compounds does not have hydroxyl group or OH group, but they are basic. Now the next theory. Next is Bronsted-Lowry theory. Bronsted and Lowry proposed a more general theory known as Bronsted-Lowry proton transfer theory, and according to this theory, acids are the substances which donate proton or hydrogen ion to another substance, and base are the one which accept proton from another substance. So basically, acid is giving hydrogen ion and base is accepting that hydrogen ion. Let's see this reaction. In this reaction, hydrogen ion or proton will be given by this acid, and this hydrogen ion will be accepted by this base, right? When hydrochloric acid is giving out one proton, it will turn up into chloride ion or Cl ion, and when that hydrogen ion will be accepted by this ammonia, it will turn up into ammonium ion. Now let's see this equation backwards. If ammonium ion is replacing, or you can say removing hydrogen ion, it is turning up into ammonia. So here it is acid, and that hydrogen ion will be accepted by this chloride ion to turn up into HCl. So here Cl is the base which is accepting hydrogen ion or a proton from ammonium ion. So Cl ion is turning up into acid. The base produced by accepting proton from acid is a conjugate base of the acid. And likewise, acid produced when base accept the proton is called conjugate acid of that base. So a pair of an acid and a base differing by a proton is called as conjugate acid base pair. So here HCl is acid and its conjugate base is Cl. Here ammonia is base, its conjugate acid is ammonium. Lewis theory. Lewis theory is given by obviously G.N. Lewis, and according to this theory is acids are the species that accept share pair of electron. They are electron deficient species. Bases are the one which can donate electron pair, maybe and they are having lone pair of electrons for donating purposes. So that is why we are treating such compounds which are having lone pair of electrons as Lewis base. Like the example you are seeing on the screen. Ammonia. In ammonia, nitrogen is having lone pair of electron, so it is Lewis base. Boron trifluoride, it is electron deficient species, so this is Lewis acid. Next, amphoteric nature of water. Water has an ability to act as an acid as well as base. Such behavior are known as amphoteric nature of water. Like you see, water is treated with ammonia, it is turning up into hydroxyl ion and ammonium ion. Ammonia is a base, we know, and here water is acting as acid. In another equation, water is treated with HCl, or we are diluting this HCl. What is happening? Here it is converting hydronium ion and chloride ion. So water is interacting with this acid, that is why we are treating it as base. So Water is interacting with acids also, water is interacting with base also. That is why we used to call the nature of water is amphoteric. Now, ionization of acids and base. Ionization of acids and base. Acids and base are classified into strong acid and strong bases, weak acids and weak bases on the extent of their dissociation. Strong acids and strong base used to ionize completely in water. Some typical strong acids are HCl, HNO3, H2SO4, HBr and HI. And some strong bases are NaOH and KOH. Weak acids and weak base are those which partially dissociate in water, and the solution of weak acid or weak base contain undissociated molecule along with number of ions at equilibrium. And some examples of weak acids are formic acid, hydrofluoric acid, hydrogen sulfide, and some weak base are ferric hydroxide and cupric hydroxide. These are the ionization of some strong acid and strong base and weak acid and weak base. So that's it, children. Meet you in the next video. Thank you.